Welcome back friends in my channel Upadhyay classes. Now in last video we have seen the comparison between SN1 and SN2 reactions. As we have found, this was the most important question in this very first chapter of the organic. Okay, now in the next video, in this video we are going to compare and going to consider some more important things. As here we are at the chirality portion. Chiral means a carbon that have all the other carbons have alag compound, means there's nothing symmetry with that carbon, so that is a chiral carbon. Okay, now a chiral that have some similarity. Okay, another definition, that if the mirror image are superimposable, so that is achiral, and non-superimposable mirror images are known as chiral constants. Okay, these are the easy sections. Okay, now the important is enantiomers. What are the enantiomers? Enantiomers related to each other, the non-superimposable mirror images. Two mirror images which are non-superimposable on each other are known as enantiomers. And another, the racemizations. Racemization means equal proportions of D and L sections. D forms and L forms equal proportion are known as racemization. Okay, and now retention. As we have already learned the retention and inversion in SN2 and SN1 conditions. That is, SN1 was a condition of retention and SN2 was a condition of inversion. Now, in retention portion, the final structure is same like the initial structure. That means you can see here the final structure and initial structure are same. Here X, here Y. Okay, so the exact structure is not changed. As in the inversion portion, you can see that this is the the position of X and Y are inverted. This is the inversion. Okay, so this is the inversion section and this one is the retention section. Okay, so here you can find the X was in this direction, now is in the opposite direction. So this is the inversion and this is the retention, same side. And this A plus B is racemization, racemic. Okay, so this is racemization, means equal proportion of A and B. Okay, now these are not the important portions. Okay, what is beta elimination? This is important a little bit. What is beta elimination? The elimination from the beta carbon is known as beta elimination. That means the carbon with which the functional group is attached is known as alpha carbon, and next carbon with the alpha carbon is known as beta carbon. So in this section you can find that this carbon is beta carbon and this hydrogen is beta hydrogen. So removal of beta hydrogen is known as beta hydrogen, and if the elimination of these two sections, so this is known as beta elimination. Okay, and after elimination, which compound will form, whether this compound or this compound will form, this is the issue. So according to Setchef rule, higher terminal sections will be preferred, means is in this section you can find 2 and 3 carbon at the terminals, and in here 4:1. So equal balance, there's needed equal balance. So this is most preferred and 81% you can see here. Now you know the Grignard reagent, nothing is important here. Okay, RMGX. Okay, Wurtz reaction. This is a name reaction. Actually, my suggestion is that you have to write all the name reactions along with your assignments. If you are getting any name reaction, you have to write here like Wurtz reaction. This one is a name reaction. Okay, in this RX plus ka Na, so 2 alkyl group is going to be prepared in this. Now, nucleophilic substitution. Haloarenes very hardly, or in case you can say that don't gives nucleophilic substitution. The reason is why. The first one is the resonance effect. These electrons are in the resonance, so this is the partially double bond character. Okay, that's why they don't allow for the breaking of the chlorine group or halo group. So partial double bond character don't allow the breaking of the chlorine group or halo group. That's why they don't prefer nucleophilic substitution, because for the substitution chlorine have to substitute away, but there's no possibility for that one. Now second reason is, this is very important, this is important case. Okay, the second is difference in hybridization. As CX bond has sp3 hybridization, but in this case sp2 is more stronger than sp3, that's why this bond don't break. Third case is instability of phenyl cation. That means if this cation is this halogen is breaking, so there's some formation of cation. Because of the formation of cation, what happens, this cation don't be stabilized at that portion, that's why this will not break. And the fourth case, because of the possible repulsion. if a compound is coming, if electronegative element is coming here, so this will create repulsion with this compound, so they don't allow to approach any electronegative compound to this product. So these are the four reasons, basic reasons, that's why these halogen groups don't follow this nucleophilic substitution. So question may be like this in the board purpose, that why the halogens don't prefer nucleophilic substitutions. So these are the reasons. Now, okay, now this section is not important. Okay, what is important? You have to make the resonance structures. I think you know how to form the resonance structure. This is the formation of the resonance structure. Means every time you have to break the electron and substitute it at every next position. Okay, now this portion is a little bit important. What the important is here, that question may be asked that which is the reacting group, means what is the attacking reagent. So here I have defined this is Cl minus and this is Cl plus. So this is the attacking agent here, as I've already told you. Why this is H, here this broke, negative can be satisfied only the positive one. So this is the attacking agent here. Here you can find HNO3, HO or and NO2, bond broke, minus plus. Only this is the sense electrophile, so this is going to react, this is going to attack here. Okay, now this group, what happened with this group, this HNO3, NO2 is going to attack, so this is the minor, this is the major one. Okay, now at the third portion, means sulfonation. If you are getting the portion of the sulfonation is the compound is the H2SO4. So in H2SO4 you can find this, you can break it as HO and SO something else, like HO and the other group is SO3H. Now you broke the bond, this is minus, this is plus. This group is going to attack on this position, so it is removed away. This portion is a major group. So this is the attacking agent. This is the important section. Now you know what the Friedel-Crafts reaction is, how it approaches. This is like CH3 bond Cl, it broke minus and plus. This is the attacking reagent that attacks. In this section same thing happens, C double bond O and Cl, this bond break minus, this is the minus, this is the plus. This group is the attacking reagent. Now fatigue reaction and wood fatigue reaction, this is the important section. How it happens, this is a group, it consumes R dash X plus Na and again Na plus X and R. Okay, so this group is removed away and R dash and R is formed. This is the group. This is to combine a phenyl group, aryl group with the aliphatic group, and the fatigue reaction is to combine two aryl group. So this is the difference between them. Okay, now in this section there's nothing important. These are only to waste the time. So my recommendation, don't read. If you have to read in this section, you have to read this. Write the question is the write the structure of TDT. Okay, so you have to form this. Okay, now we have to jump for the questions, but we will discuss the questions at the end of the every session. Means if we are about to consider, so we are going to that one. Okay, so I hope you will subscribe my channel, and possibly for the next incoming videos that are more important and that are going to fetch more and more marks for the board purpose. So please subscribe my channel, please share that on.